Hi, we are back in Mumbai for another episode of This is My Architecture. I am Abhishek from AWS and with me I have Piyush from Capillary. Welcome Piyush.
Thank you.
So Piyush, tell us a bit about what Capillary does and how does it use AWS?
Capillary is a multi-tenanted SaaS platform that provides customer engagement solutions to retailers and brands. We use AI and ML quite heavily to try and understand the customers deeply and help brands engage with them accordingly.
Fantastic. And that's a platform that you have here on the board and we're going to talk about it.
Yeah.
So take us through how you work with it.
Sure. So what we are going to talk about here is how we leverage this architecture to understand customers better. What happens is that because we are a multi-tenanted platform, each tenant have their own way of engaging with customers and understanding their customers. Some would want to understand pre-transaction behavior. Some would want to understand customer behavior based on ratings and comments. Some might want to gamify their experiences and understand those. Building each of these events inside the platform becomes extremely cumbersome and time taking, and the brands can't get onboarded with those events on the platform quickly enough. So what we have done is we have given the users, the configurers of the platform, a way to come into the system via the ALB and through our APIs, which is running on a Kubernetes cluster, to define their events. So they define their events, their event attributes, the validations, what kind of workflows to have in the system and so on, which gets persisted into the event meta store here in DynamoDB. Then they get a webhook which is very specific to this event and the tenant, and they go ahead and register that webhook in their third-party event integration system.
Interesting. So because it's a multi-tenant system, so you're dealing with multiple retailers. Each retailer has their own events, and you give them full flexibility in terms of what an event is, how you want them to define their event, and that gets stored in DynamoDB.
Yeah.
And the webhook essentially is what they integrate in their applications. Right?
Yeah.
So take us through how that works.
So once they have integrated it into their application, once the user has gone ahead and done an event, for example, let's say they have rated a particular product.
I see.
That event flows into our system through the API gateway, and then comes into the webhook Lambda that we have. This webhook Lambda reads the metadata of the event from the DynamoDB and figures out whether it is from an authenticated source, which tenant it is from, and so on, and then takes that event and passes it into an SQS.
I see. So, generally when we see API gateway, we have an API hosted on servers behind it, right? Now, interesting choice, you're using Lambda for processing these APIs. So, can you share some details on why you went for Lambda here?
So, one of the things here is that the nature of these events is not very regular, not very predictable. The popularity of the website, a flash sale being run on it, suddenly a game becoming very popular at certain stage, any kind of promotional event being run at some point, they suddenly cause bursts in volumes. At that point of time, there is a flood of events that come into the system. So when they come into the system, the webhooks here scale up and down quite fast. The Lambda here could scale up to like 10 times of the number of servers running here, and then could suddenly come down to a very small chunk.
Great. So that's more of a mechanism to handle scale.
Yes.
Can you share some numbers around what sort of scale we're talking about?
So we normally would see up to somewhere in the range of 10 million events a day. But in case of burst volumes, these numbers could swell to the same volume running within an hour or so.
That's significant. That's significant spike. And so you process it and then you park it in a SQS queue for further processing everything. So can you take us through what happens next?
Yeah. So once the events are parked into SQS, there is another Lambda, which is the processor Lambda sitting in behind, which is a consumer to this SQS. This also scales up and down, not at this scale, but depending on the number of events here, it scales at a slower pace.
So the total number of messages basically define how many Lambdas you need. Okay.
And then it figures out based on the event definition what all actions to take on this. So it could plain go ahead and persist this event in the DynamoDB, which would be further used for pure analysis. There are other events which it would flow through kinases, which would be further processed. And then from kinases, there are other workers that will take it and flow it into the system for further processing.
I see. So essentially over here you have kinases where you're putting in all the events that need to be further processed, and these are workers from different retailers, I believe, who would accordingly process it, right?
So these workers are our own workers running inside our multi-tenanted platform, but they help facilitate different kind of actions on those. So some of these events could lead to allocation of points for the user. Some of these could be sending out a thank you message to them if they have provided feedback on a particular product. It could lead to giving them another promotion or unlocking another stage of the game for them. Yeah.
Great. So I think this is great. So what's next? How do you intend to iterate and build on top of this?
So one of the things that we have in our mind is that the processor Lambda that we are using here has multiple responsibilities. We are looking to break that down into more granular Lambda and use step functions to orchestrate that entire workflow.
I see.
Yeah, the other thing that we are looking to do is on the KA test that we are using, we would want to evaluate the Amazon Kubernetes management to offload the infrastructure management of this part.
Okay, so that way you focus more on the application and leave the handling of the cluster to Amazon itself.
Absolutely.
Fantastic. I think there's plenty of learnings out of your architecture. Thank you very much for coming and sharing how you built your architecture with us.
Thank you.
And thank you for watching another episode of This Is My Architecture.